Hi, hello, and good morning to everyone. I will be starting the webinar for today. I'll be the speaker of today, and with the topic of Securithon ASD and solution for clean room. Before we start, I'd like to remind those who have just entered, please switch off your microphone and cameras. And if there are any questions, you can also write in to us later, or we can drop us an email as well to get more details about the presentations or our product. And once again, thank you for joining another interesting webinar from Securithon. A warm welcome to all the online participants today. So without any further ado, we will proceed with the agenda for today. That we'll have a six main topic which we'll be covering. I will start with the problem statements, certain information about fire causes and casualties in clean rooms, followed by understanding about clean rooms and types of clean rooms available around the world. And third, I will be also explaining on fire standards, code of practice, that inclusive of EN norms, European norms, NFPA standards, as well as British standards and some other related standards governing the clean room application. I also will be talking about the clean room of using the ASD as a solution from Securithon. And I do a little comparison between a normal point type detector as well as with the ASD. And then we will conclude the entire presentation for today. With that note of information, I'll explain in detail soon. And the speaker, which is myself, my name is Satya Seelan Krishnan. You can also call me Seelan or address me as Seelan. And I'm with Securithon for the last 16 years, mainly taking care of all the Securithon technical support related to the CERS International within the organization. My expertise will be as well as fire system and special fire detection within the company. With that, we will go into the first problem statement before we understand about the system and about the clean room. We need to know why we need to go into this solution when we can look into the fire causes in the semiconductor industry. Mainly clean rooms related to semiconductors, but we are also will be explaining in details, aside from semiconductor, what other industry which is correlated with clean rooms as well. So the main causes of incident in clean rooms, if you look into it, it will be the electronics machines, the electrical work distributed cabinets, the failures in the overheat cables, and those are some informations that we gathered from the previous incident. Besides that, the failure of the process equipment itself, the workbench and the heater failure and the boiler malfunctions is another types of causes which leads to fire incident in clean rooms, as well as coexistence of various highly flammable gases and chemical substance. This is when we look into the clean room application in chemical industry or the medical industry we're talking about. Aside that, we also have the operation errors like from the leakage of oil and gases. So these are the common causes that actually contribute to the fire incident in clean rooms. If you look into the incidents that pass informations, which I could collect from some information from the journals, the main cause of the incidents are usually because of fire, happens for various reasons from mentioned above. Second was the explosion without fire, which happens in medical applications most of the time. And third is the release of hazardous material. This is also related to the medical industry application, where the hazardous materials or chemicals is being used, as well as explosion and fire incidents also. The number of occurrences as shown here. So these are the common causes of incidents. And with that, the consequences is, of course, the fatalities are 11 numbers have happened in some research within this years, which have collected, and injuries as well as economy loss. Economy loss is including of the material lost, rebuilding the entire productions and whatsoever not after the fire incident. So that's a huge amount of investment and after investment or reinvestment happens in that part of it. Mainly the incidents, I've collected some information within the US as well as Asia. Those are the two main key players in terms of semiconductors. Throughout the year, was in the sense of the booming of semiconductor industry, whereby mostly the injuries happened in the US is narrowed down here. Mostly the incidents are from the hazardous gases, if you can notice, explosion and fire from the exhaust dust, as well as the release of NO2, which is also again chemical. So these are the common causes that the injuries can happen. And you can see the number of, even though the fatalities are zero, but the injuries are recorded, and the number seems slightly increasing and decreasing as well as increased throughout the years. So there's inconsistent, but there is an injuries happens to the semiconductor industry fire incident. We're talking about Asia. We also have incidents from Japan, which have collected for information. It's again, the possible causes record is also shown from the supply systems, error in the operations and surface and exhaust duct ignitions of fire, and mostly the errors in the operation, which sometimes can be avoided and most time cannot be avoided. Okay, so that we need to look into the earliest possible of protection in order to lower down this injuries or fatalities. And as you all know, Taiwan is one of the major producer of chips or integrated circuit ICs. So they also this research is also we found out that the loss are quite significant in terms of the numbers, as we can see. In 2019, for example, the global clean room technology market size was around 3.7 billion, and it's expected to grow at the rate of 3.8% in 2022. And up to 2023, that's the estimated, which is 5.3 billions. So what drives the market? So the market is estimated to be at the rate of US 62.4 billion by 2023, 2024, which is now. And this is from the Times Magazine, the information is collected. And if this is a growing market, there's lots of opportunity for ASDs to be installed. At the same time, there is needs for better protections and to understand how we can actually to give the best protection towards the semiconductor industry as well. Besides that, there's a telecommunications is also plays the role where the clean rooms are into the market, and the segment is also growing in coming years. And so there's more IC fabrications needed to be built as well. This is the information same collected from the magazines. So with that, all the informations that we have, the previous fire incidents, as well as the reasons in the future that we need to clear. So we need to understand the causes of the fire incident, which is also mentioned in the first slide. So I've narrowed down certain common issues that we feel in clean room industry. There will be a short circuits. So the clean rooms are designed in where the machineries and equipments are placed, and sometimes overloading or overworking conditions can also leads to short circuit, that which will cause us fire or catches the fires in the clean room. Second, we have this improper handlings in heat sources, because as I mentioned earlier, aside from semiconductor, we also have chemical industry, chemical clean room industries, for example, aerospace, defense, clean rooms, and whatsoever not, as well as this mishandle of the stored or improperly stored can also leads to disastrous damage as well. Number three, the leakage from highly flammable materials, which I also mentioned for the clean rooms in industrial clean rooms for medical applications will have a lot of gases, liquids, and the air moisture can actually a poor design or a leakage will actually leads to explosion, followed by a fire incidents as well. Good. So with that understanding about the causes, we need to understand what is clean room in the first place in order to design accordingly. So in order to understand that, we need to understand what is clean room. So a clean room is a facility utilized as part of a specialized industry production for scientific research, including the manufacturing and pharmaceutical items and integrated circuits, which is IC. And mostly clean rooms are designed to maintain extremely low levels of particulates, such as dust, airborne organisms, and vaporized particles. So it is clean rooms. It means it's cleaned, so the air completely low in terms of dust. So the question would be, how do you contain the air particulates? By using a filter, for example, filter for sure. So that's we will using a HEPA or ultra low penetration air, which is ULPA filters, to filter the air before going into the clean rooms. So, so the clean rooms will be classified according to certain standards, which formerly it was known as FED standards, which is 209E, but now it's superseded by ISO standard, which I'll be explaining on the next slide. So clean room is a room where you have a clean air to do works, because ICs, manufacturing or the fabrication, needs very low dust level or zero tolerance of dust. With that information, as I mentioned about the clean rooms, as the blue color here on your right indicates the older classifications or standards which has been used to classify class A up to class 100,000. So that is to understand how they're classified. So the class is indicate the level of particles, which is equal or greater than 0.5 microamp. Cubic meter, they will call it. And a clean room is that design in this classes has to compromise to certain things. So for example, avoid manufacturing, warehousings and business operation in ISO standard. Now we look into ISO standard, which is 1 to 9, yeah? So that's easier to understand, because like ISO 1 and 2 usually or typically found in large fabrication, or they call it fab fabrication, and ISO 3 to 4 like production laboratories and electronic integrated circuit manufacturing places. They're probably using 3 and 4. And like ISO 5, 6, and 7 areas like photo labs, medical implants, and 7 usually in low scale of TV tubes and hospital operations and theaters. And ISO 8 for productions of ball bearings and like higher industrial level. So the smaller the number, the smaller the microns of filtrations needed. So basically, this class represent how they design the clean room. Okay, so when the design came into the picture, there are quite a number of places that AST has to play the role to capture the smoke, which will be explained shortly. Now, examples of clean rooms in the industry, aside from semiconductor, which is majorly the things we're going to look into, but obviously there are other rather than the semiconductors. Basically, as I mentioned, the macroelectronics clean rooms are the top level, because they are the common clean rooms available around the world. Aside that, we also have biotechnology and pharmaceutical clean rooms that contain major concern types of clean rooms, and they're crucial for maintenance and cleaning surfaces. Aside from that, we also have medical device clean rooms, defense industry clean rooms, R&D research clean rooms as well. Okay, so these are the common clean rooms that we have aside from semiconductor. Now, if you look into clean rooms, there are fire standards and code of practices used to design fire systems. Not only fire system, there are also classifications on how you design, fabricate, as well as to maintain the sites from fire as well. So the standards we're going to look into today, just a rough idea what are the standards used in European markets. Obviously, we will using EN 54-20 or European norms, Part 20 for AST. And if you look around the world, the American standards, so they have NFPA 318, which is standard for protection of semiconductor fabrication, that mainly talks about sites from fire protection. They also talks about how do you install, how do you the air is circulated, and all the norms related to semiconductors are mentioned in 831. And aside from that, the NFPA 76 and 75 can be used or shall be incorporated for equipment protections. That will be a telecommunication facilities and fire protections for IT equipments as well, which is equipment monitorings and ceiling void and raised floor. So as I mentioned earlier, clean room application mainly into, if you go further details, NFPA 318 talks about the semiconductor fabrications and requirements needed for the fabrication to be following certain guidelines, and as well as how the AST shall be placed and where other sampling places should be used according to the standards. The listed approvals for detection, they are also the point where the makeup air occurs, which I'll be explaining on the next slide. And the air exit, like air makeup, is like how the air circulations in and how do the air circulated out. Okay, so that's the information. So in between, there are certain places which we need to cover in terms of protection. So that's from the standards I've derived from the NFPA 318. As I mentioned, on your left, you can see there's a makeup air unit, and it goes into the mixing box, whereby the air handling unit or the AHU circulate the air in back to the plenum or the air supply plenum, where to the fabrication area, as well as sub-fabrication area, and the air returned back to the duct and back to the mixing box. So there are few number of areas that the air circulations is going in, and these are the places how we design with AST to capture the earliest possible of incident and to minimize alarm incidents or fire incidents as well. Okay. With that information from the previous slides, we will go into the clean room applications using our AST solution from Securiton. And the main objective of this clean room detection would be obviously to make the better response time, the immediate shutdown to minimize any contaminations of airflow, which leads to fire or explosion. Initiation of smoke control systems. That means you can get early informations that it can be contained for further damages. Of course, better assurance compared to the ceiling mounted smoke detector, which I will be also explaining in the comparison between a smoke detector or the other word point type smoke detector and AST. And of course, at the same time, we have to minimize the low nuisance alarm rate because it's clean room, so it can be false alarm as well. So how do we do that with AST as well will be cleared in this presentation. Now, if you look into the clean rooms, they from your left, you can see there are quite a number of areas that involved. First would be the room monitoring itself, that's the clean room, and the equipment monitoring, which is the equipments inside the clean room, as well as the sub-fab. Clean rooms is also known as a fab, and the air return, the floor void monitoring, and the ceiling void monitoring. So there are quite a number of it. As you can see, the MUA on your left, which is the air coming in, is actually the make-up air unit, which goes into the FFU, which is the fan filter unit, goes down towards the RAH, which is the return handling unit. So it goes into the clean room for working, and it goes to the sub-fab or the sub-clean room and back to the RAH return. So it's a circulation and quite a number of places, which is MUA, FFU, the clean room, the sub-clean room, and air handling return or AHU. These are the common places which we have in a clean room application. With that, here it's shown how we place an AST and the common areas which we need protection according to the standard which I've explained in 318, 78, and 76, as well as I've took some of the information from FIA code as well. On your left, you can see the supply air room. It's also the first, as you can see that it's numbered, number 1, number 2, number 3, 4, and 5. So number 1 is where the air makeup area, which I mentioned earlier, the air is cleaned and goes into the FFU, into the fab area. which you need a protections at the clean room area or the makeup area. And then it goes down to sub fab, which you need another protection as a secondary protection. And third protection, which is the air return. And 4 and 5 would be the air return and the air duct return as well. Okay, so the advantage with our ASD, as you can see, with one single ASD, we can cover up to 2 zones. So you minimize the number of ASD used here with the solution from Securiton. In fact, if you have equipments, which I'll be also sharing on the next slide, we can further use REK solution, whereby you can address the individual racks inside the fab and sub fab areas. In the fab and sub areas, you will have equipments. So these equipments can be individually monitored, being addressed as well of the incident, if there's a fire incident on a specific equipments, by using a special detectors called REK, which will be incorporated into the ASD. The maximum of 8 number of REKs or 8 addresses can be located within can be designed together with one ASD, and all this information can be given to the third party via a relay contact, which also can be given through our networking system as well, to be shown in a remote access as well. Good. We look into the fab areas, sub fab areas, and we also now goes down. The third example will be the floor void. As you can see, as we are aware that the air circulations inside the clean rooms will be drastic, or the airspeed is in a in a high movement motion, so that it needs a certain adjustment in terms of the standard distances in the sampling hole. So with that, I took an information from BS 6266, which whereby when you see an air sampling in a greater speed of or air circulations, the sampling units or the sampling holes has to be closer. It's from 1.5 up to 25 meters square. Okay, so this is for the consideration of airflow sensitivity as well. And at the same time, I also took for the information from the NFPA 76 is also mentioned approximately 18.6 meters square up to 37 meters square. So approximately 4 to 6 meter, depending on both standards, if you are using it, to have a distance between one point to another point. Now, the last one, as we covered about the air inlet, as fab and sub air, and as well now to the air return, which is the air finally returns back to the AHU or back to the air makeup area units. So here you will have a rapid air, which is extremely high flow of air going through the grills, where in this we have to follow NFPA 76 as well as FIA code. We can mention that the air grill area which shall be covered with more than one number of smoke sensor or point, whereby 0.4 meters square of a coverage is recommended. So there you should, if you have more than one grills, and each of these grills shall be covered with one ASD, or in our case, we can use 2-zone ASD to cover more than one grill as well. Now, as I mentioned earlier, that's the application. Now we look into, because the standard also mentioned the minimum requirement for protection would be a point type detector or a smoke detector. But always the question arises that people comes to me and ask, okay, if I can use a point detector, why should I use ASD? So then here I do a comparison. What is the benefit of using an ASD compared to a normal point detector? Obviously, if you look into the sensitivity, it's much more sensitive. As you can see, we need the earliest possible time to capture the smoke, and the earlier possible way to stop the fabrications from going on would be greater with the ASD. Why? Because we have 0.002 OBS per meter in terms of sensitivity, is far beyond the normal point detector. And if you look into the detection principle, it's an active detector. Why we call active? Because actively sampling the air towards the network tube, and it's evaluated, as well as if you look into the point type detector, it's a passive, it sits there and it waits for the smokes to travel towards it. So it's a longer period of time to capture it. In terms of adjustable, yes, ASD is possible to have pre-alarm 1, 2, 3, and a main alarm. Instead of a point detector, you shall not able to do this so. And in terms of different levels, as I mentioned earlier, you might have alarm and alarm 2 probably in a point type detectors or pre-alarm and alarm. But in case of ASD, you have more pre-alarm 1, 2, 3, and you can differentiate this and you utilize this alarm as well as an alarm or as a pre-alarm. Okay, and the other advantage with each and individual of this point detector in the area of sub and subfab and air return, you need to maintain. It will be difficult for the maintenance to be carried out. Whereas on the part of the ASD, you only need one ASD or a number of ASDs to cover the entire system. So only this 2 ASD has to be maintained. And in terms of coverage, obviously, one single ASD can go 2,000 meters square or less than 2,000 meters square according to the BS standard, whereby you need about 40 approximation number of point type detector to cover the entire fab, subfab, air returned, and whatsoever not for better protection. As I said, the airspeed, you need more number of smoke detectors as well. In terms of the maintenance, of course, it's going to be more costly and more time consuming as well. Okay, in terms of functionality test, it's easier to just test at one point or the last sampling hole from an ASD, whereas on the point type detector, you have to go to every or each and every ASDs or detectors to be tested. Okay, so this actually gives you a clear picture why ASD plays plays a major or a better contribution in terms of BAS detection compared to a point detector. So with that note about the information, we will go into the benefits of using our ASD 535, whereby we have a large volume smoke chamber type of smoke detector for early detection. It's an aerodynamic, whereby it can go from 0.002 OBS per meter in terms of detection, and it can cover larger areas. Okay, since we has two number of sensors, it can go 2 times the coverage area that other point or other detectors in the market could able to do. We also have the pipe flow calculations and the flow metric, asymmetric or symmetric calculations possible, and it's VDS approved calculations that you can design and simplify the projection before going to the site. And we also have the ASD config, which is a software used. And to be mentioned here, we can also commission the system without the software. So we have easy config as well as ASD config. And we have all the accessories to cater for applications, for normal application as well as for clean rooms. We also have all the relevant tubes, flexi tubes, as well as other components which is needed for semiconductor industry as well. And to be mentioned, we have a very powerful fan or aspirator, and at the same time, it's low in terms of the noise, which is ideal to be used for clean room application as well. Sorry. And the last one, we also have additional accessories that we catered with the ASD that can be connected to third-party systems or our own systems as well. To be mentioned as well, if you're looking into this fabrication, we might need more than one ASD. When more than one ASD presence, there is networking possibilities with Securiton. In the case of that, we can connect them through a LAN, or we can also connect them through RS485 technology from 1 up to 250 or 100 number of if you're using a LAN, and it can be connected to a remote control unit. We call it RCU. It can be displayed, show all the information, and we also releases a Modbus protocol for third-party monitoring as well. So this remote control unit can possible for easier maintenance from one point, rather than going to each of the every ASTs. At the same time, you can also view all this information of alarm, pre-alarms, the status of the AST from the remote control unit. And all this information which I've carried out today, some of it taken from the standard, some of it taken from our own design guides and case studies, which is available in our portal and can be accessible for those partners, and those who are not, you can contact your respective area sales manager from each countries, and they will be happy to send you these documents for you to get more details or in-depth details knowledge about each of the products. Aside from the clean room application that we're talking about, we also have other types of it, which you can get it from here. Last but not least, I have to mention about the software. We also give trainings how to use the software, which is the pipe flow calculation, which will ease your design into a fast manner where you can design and you can incorporate it into your design and a real application. It does all the work, and the PDF can be used as a BOQ as well as a design, and to give to the end users to do the pipe handling according to the pipe flow. With that, I would like to conclude our presentation for today with the ASD. So why we should use our ASD, because we have a very high sensitivity and adjustable over a wide range of application, and it's a long life cycle due to it has a pulse filter, and it's a better technology, patented technology, which you can work for a longer period of time. Mean time between failure for our products is approximately more than 10 years. And to be mentioned as well, that temperature range is also wide, where you can go from -30 up to 60 degree, and it would be a very cost-effective solution compared to point tap detector or any other aspirator in the market, because we have a dual zone, and we can also have a REK incorporated that can further addresses the system in the clean room application. And to be mentioned as well that all our products are global acceptance from VDS UL approved, and we have FM approved as well, and CCC and RoHS compliant, and many other to certain countries in Asia, Middle East, as well as around the world as well. With that, I wish to end my presentation, and thank you for all the participants who have joined for today's presentation of the clean room application. And with that, I will hand over to Mr. Zach. Back to you, Zach.
Thank you, Seelan, for the presentation. We've got a few questions, and the first question is, what is the coverage area for rapid air movement in the semiconductor application?
Sorry, okay. So, well, in general, the spacing of the sampling ports of ceiling detections and void, as I mentioned, according to the BIS standards, that's approximately 25 meters square, which is 1.5 meter. It's based on the consideration of the airflow again. So you can use both standards that you can, if it's larger or smaller, or the airspeed, you can go from 25 meters square up to 55 meters square.
Okay, so next question is, how do we solve clean rooms with medical applications where chemical gases are present in the environment?
Okay, so yes, with our ASD sampling unit shall be fitted with the air return concept release to the gas that gases back to the same zone, which means the ASD shall be kept outside, and we have an air return that will be returning those chemical and hazardous gases back to the same environment, and that will not cause any issues on it as well. Yeah.
The next question is from an attendee, and he's asking, in a clean agent room, do we need to use another type of detection rather than ASD to confirm the cross zoning?
Okay, for cross zoning, no, absolutely not, because you can also use our ASD. We have cross zone by doing dual ASD. We have ASD -2 and 4, whereby you can have the cross zoning possibilities. But normally, according to standard, is not required. But in case of the end users wanted to use it as a cross-zoning, it is possible with our ASD.
Then we also have a question about to learn the Pipeflow software, how they can get training. So here I would like to say a few words. So we have a online training platform called LearnBits. So please register at LearnBits, and then we will grant you an access. Another question, Seelan, for you is, can we use the same ASD in different airspeed rooms at the same time in clean room applications?
Yes, but it's recommended to have a different number of ASDs because of the airspeed. Though the airspeed is not drastic, but there's an advantage to using in Securiton ASD. Why? Is because one ASD has 2 zones, whereby it can cover 2 zones with one single ASD. So there's an advantage over that question. Yeah.
The next question is, do we need air sampling return design for ASD in a clean room?
Yes, it's recommended. Again, it's a question of a recommendation, because placing the ASD, if the ASD is out from the common detection area, it's rather good to have the air return back. It's recommended to have the air return back.
Okay, and then the last question for today is, what is the protocol for ASD information and signals to any third-party building management systems in clean rooms application?
Okay, as I mentioned the last 2 slides before I end the presentation, that we have this RS485 or a LAN connections that can be send those signals to a remote access or RCU. From the RCU, we deliver a Modbus protocol, which is proprietary protocol that can send all this information to third-party systems from any PLC or BMS systems available in the market.